Millions of years ago, herds of dinosaurs roamed prehistoric landscapes, leaving behind footprints that still tell their story today. These footprints, etched in stone, are more than just impressions. They are echoes of an ancient world, whispering secrets of the past. Fossilized trackways, ancient footprints preserved in rock, reveal how dinosaurs traveled, migrated, and interacted in groups. But what do these fossilized trails teach us about their behavior? Let's explore the epic migrations of dinosaurs and how their footprints have unlocked secrets of the past. In the vast expanse of time, stretching back millions of years, the very ground beneath our feet holds a remarkable record of the past. It is in these ancient layers of rock that we find fossilized dinosaur tracks, a testament to the incredible creatures that once roamed the earth. But how do these tracks, made in what seems like fleeting moments, survive the relentless march of time? The process begins with a simple step, a dinosaur pressing its foot into soft mud, sand, or even volcanic ash. This impression, however, is ephemeral, quickly erased by the elements unless fortune intervenes. For a footprint to become a fossil, it must be swiftly buried, shielded from the erosive forces of wind and rain. Over eons, layers of sediment accumulate, burying the footprint deeper and deeper, encasing it in a protective tomb. As the weight of overlying sediment increases, the sediment itself undergoes a transformation, hardening and solidifying into rock, forever preserving the shape of the footprint within its depths. Millions of years pass and the forces of erosion, the very forces that would have obliterated the footprint at its inception, now work to reveal it once more, carving away layers of rock to expose these ancient traces of life. What makes these fossilized tracks even more remarkable is that they sometimes preserve more than just the shape of the foot. In some cases, impressions of skin texture are visible, providing a rare glimpse into the physical characteristics of these extinct animals. Like detectives piecing together clues at a crime scene, paleontologists meticulously study fossilized dinosaur tracks, extracting a wealth of information from these ancient impressions. Each trackway is a treasure trove of data, revealing insights into the lives and behaviors of these long-extinct creatures. The size and shape of the tracks themselves are telling, allowing scientists to determine the species of dinosaur that made them. Different dinosaurs had distinct foot structures, leaving behind unique footprints that act like fingerprints, identifying the track maker. But the tracks reveal far more than just the identity of the dinosaur. The distance between footprints within a trackway, known as the stride length, provides clues about the dinosaur's walking speed. Short, evenly spaced footprints suggest a leisurely stroll, while long strides with a wider gap indicate a brisk pace or even a desperate run. Perhaps the most fascinating insights gleaned from fossilized trackways relate to dinosaur social behavior. Parallel trackways, multiple sets of footprints moving in the same direction, strongly suggest that dinosaurs moved in herds, much like many modern-day animals. These herds could range in size from a few individuals to massive groups numbering in the hundreds or even thousands, offering safety in numbers and facilitating long migrations. In some cases, fossilized trackways capture moments of drama, preserving evidence of predator-prey interactions. The presence of both carnivore and herbivore tracks in close proximity, with the carnivore tracks sometimes overlapping the herbivore tracks, paints a vivid picture of a prehistoric chase, a life-or-death struggle frozen in time. By carefully analyzing these fossilized trackways, paleontologists are able to reconstruct ancient ecosystems, gaining a deeper understanding of the complex web of life that existed millions of years ago. Across the globe, from the rugged landscapes of North America to the remote deserts of Asia, paleontologists have uncovered fossilized trackways that tell a compelling story of dinosaur migration. These ancient trails, etched into the earth, provide compelling evidence that some dinosaur species embarked on epic journeys, traversing vast distances in search of food, water, and suitable nesting grounds. One of the most striking examples of dinosaur migration is found in the massive trackways left behind by sauropods, the long-necked giants of the dinosaur world. Sites like the Dinosaur Freeway in the United States and the trackways of Gansu, China, preserve thousands of sauropod footprints, forming extensive trails that stretch for hundreds of kilometers. These trackways reveal that sauropods often traveled in organized herds, with smaller, more vulnerable individuals positioned in the center, shielded by larger adults. The sheer scale and directionality of these trackways strongly suggests seasonal migrations, with sauropods moving across vast landscapes in search of food and resources. Another compelling example of dinosaur migration comes from the fossil record of hadrosaurs, the duck-billed dinosaurs. Fossil evidence from Alaska indicates that these plant eaters migrated south to warmer climates during the winter months, seeking refuge from the harsh Arctic conditions. These migrations may have taken hadrosaurs across vast distances, possibly spanning the entire continent of North America. The evidence for dinosaur migration is not limited to a single continent or time period. Fossil trackways from around the world tell a consistent story of dinosaurs on the move, adapting to changing seasons and environments. Chapter 4. While evidence suggests that many dinosaur species engaged in long-distance migrations, it's important to remember that the dinosaur kingdom was incredibly diverse, encompassing a wide range of sizes, diets, and habitats. Just as in the animal kingdom today, not all dinosaurs felt the need to migrate. Some species were content to remain in a relatively confined region, their needs met by the local environment. Migratory behavior was likely driven by a combination of factors including the availability of food and water, suitable nesting grounds, and the need to escape extreme weather conditions. Dinosaurs living in polar regions, for example, would have experienced dramatic seasonal changes, with long periods of darkness and limited food availability during the winter months. For these animals, migration would have been essential for survival. Similarly, dinosaurs inhabiting regions with distinct wet and dry seasons may have migrated to follow the rains, ensuring a consistent supply of food and water. In contrast, dinosaurs living in tropical regions where resources were abundant year-round may not have had the same pressures to migrate. These animals could remain in a relatively small area, their needs met by the lush vegetation and plentiful water sources. The decision to migrate or not was ultimately a matter of survival, with each species evolving strategies that best suited its environment and lifestyle. Chapter 5. Picture a vast prehistoric landscape, the ground trembling beneath the weight of a migrating dinosaur herd. The air is thick with dust and the sounds of heavy footfalls as hundreds, perhaps thousands of dinosaurs embark on an epic journey. While we can't travel back in time to witness these migrations firsthand, fossilized trackways provide tantalizing glimpses into what these events might have looked like. Drawing parallels with modern-day animal migrations, such as those of wildebeest in Africa or caribou in the Arctic, paleontologists have pieced together a likely scenario for dinosaur migrations. The journey would have begun with the gathering of herds, smaller groups converging into larger, more cohesive units. As the herd set off, instinct would have guided them, an innate sense of direction passed down through generations. The pace of the migration would have varied, depending on factors such as the availability of food and water and the presence of predators. During times of abundance, the herd might have moved at a leisurely pace, grazing as they went. However, when resources were scarce or danger threatened, the pace would have quickened, the herd driven by the need to survive. Within the herd, there would have been a distinct social order, with larger, more dominant animals taking the lead and protecting the more vulnerable members. Young dinosaurs still finding their footing in the world would have stayed close to their mothers, seeking safety in the heart of the herd. The migration would have been a time of both opportunity and peril. While it offered the chance to find fresh grazing lands and breeding grounds, it also exposed the herd to predators, exhaustion, and the challenges of navigating unfamiliar terrain. Chapter 6. Over millions of years, Earth's climate has undergone dramatic shifts, profoundly impacting life, including dinosaur migration. Dinosaurs adapted to changing environments, altering migration routes or facing extinction. Climate change affected plant life, forcing herbivorous dinosaurs to follow their food sources. Droughts and volcanic eruptions further challenged dinosaur migrations. The Chicxulub asteroid impact triggered a global extinction event, ending the age of dinosaurs. Outro. The fossilized trackways of dinosaurs scattered across the globe offer a poignant glimpse into a lost world. These ancient footprints, preserved for millions of years, tell a story of highly social creatures, traveling in herds across vast distances, their lives intertwined with the rhythms of the natural world. Their footprints, like a prehistoric roadmap, guide us through their world, showing us how they lived, moved, and even survived in a changing world. The footprints of dinosaurs are more than just tracks. They are the echoes of an ancient world still telling its story today.